So pre-calculus is going to prepare you for calculus. Now, when you reach this point, you should have already accumulated the basic knowledge and skills in algebra and geometry. These are the skills you will need in order to be successful in pre-calc. Now, what I will concentrate on in this first part of pre-calculus is the distance and midpoint formula, plotting points on a graph by hand, and finding the intercepts. But before I do so, take a look at this graph. This is a two-dimensional rectangular coordinate system. We can also call it the Cartesian coordinate system. The horizontal line is the x-axis and the vertical line is the y-axis. And right there at the center is the point of origin. I want you to also notice how this graph is split into four boxes. Each of these four boxes are called quadrants. This side is called quadrant 1. I'm just going to put Q1. Q1, which is quadrant 1. This side is quadrant 2. Underneath quadrant 2 is quadrant 3. And underneath quadrant 1 is quadrant 4. Okay? Take a look at the center. Take a look at the point of origin. Now, when we head when we head right along the x-axis from the point of origin, the number increases, and they are all positive. From the point of origin, heading right, the number increases, and they are positive. Now, at the point of origin, heading left, the number decreases along the x-axis, and the numbers are negative. Now, starting at the point of origin, heading up, the y-axis, the number increases, and they are all positive. Starting at the point of origin, heading down, excuse me, the number decreases, and they are all negative. Okay? I'll let you look at that for a second. So what I'm going to do is plot a point on the graph. I'm going to plot a point on the graph. Okay? Uh, let's say I plot a point right here. I'm going to plot that point right here. This point is located where x is -4 and y is 6. And that's in quadrant 2. These are the coordinates, and we will write it like this. -4 and 6. That's how we would write it. Because as you can see, x here at x equals -4, y is 6 at this point. Okay? At this point. The -4 is going to represent the x value, and the 6 is going to represent the y value. Here's another point. Here's another point I will plot. At this location, the coordinates are where x is 2, y is 3. and this is in quadrant 1. And we will write this like this: 2 and a 3. And here we have the same labeling. The 2 will represent the x value, and 3 will represent the y value. And since we have 2 points, let's initialize them so that we know that they are different points. So we would call this point over here P1, and we will call this point over here P2. So for point 1, we can say that x1 is equal to -4 and y1 is equal to 6. And for point 2, we can say x2 is equal to 2 and y2 is equal to 3. So let's go ahead and label these just as such: x1 and y1, and then we have x2 and y2. So now I have two sets of coordinates: P1, which is -4 and 6, and P2, which is -5. Oh, I'm sorry. I wrote the numbers. I wrote the numbers wrong right here. P2, which is 2 and 3, and P1, which is -4 and 6. So what is the distance between these 2 points? What is the distance between these 2 points? In other words, how far are these 2 points from each other? How far are they from each other? Well, we could find that out by using the distance formula. And it looked like this. So remember when I initialized our points, I said that P1 is equal to X1 and Y1, and P2, which is point 2, is equal to X2 and Y2. So let's write that down. And P2 is equal to X2 and Y2. They're the same coordinates we are using. We're just replacing them with X1 and Y1 and X2 and Y2 for now. So let's insert our coordinates into the formula and calculate the distance between the 2 points. So we say that x1 was -4, right? And we said that y1 was 6, right? And then we said that x2 was 2 and y2 is 3. So now let's do the formula. Let's go ahead and block this off so it doesn't confuse you. All right, so x2 is 2 minus x1, which is a -4, right? Squared plus y2, which is 3, minus y1, which is 6 squared. And all of this here is square rooted. Okay? So let's go ahead and simplify what's inside the square root. Because a 2 minus a -4 will give you a positive, right? So instead of 2 minus a -4, let's write a positive right here. Let's write a positive. Okay? So now, let's go over here and do what's inside the square root to simplify. So we have inside the square root. This is the same problem, nothing that basically we just breaking it down and calculating it. So 2 plus 4 is 6 inside the parentheses. So and 6 squared is 36. Okay. Plus, let's see, we have a inside the parentheses we get a -3, and -3 squared will give us a 9. So in other words, 36 plus 9 is 45. So we have, when rewriting it, we have P1, and at point 2, the distance is square root 45. Now, if you know your algebra, you know that we can split these down, this what's inside the square root, because 9 times 5 is 45. So we can split these down. And that's why I said you should already know your basic algebra skill. So now we split that down. The square root of 9 is 3. The square root is 5. We don't know that. And since we don't know that, it just stays inside the parentheses. And here we go. So the distance from point 1 to point 2 is square root 3. Is 3 square root 5. So if we use our calculator and calculate that through the calculator, let's see, 3 and square root 5 will give us 6.7, or to round it off, it'll give us a 6.71. So we can say our distance from point 1 to point 2, since we haven't given it a unit of measurement, we can say it's 6.7 feet, 6.7 inches, 6.7 centimeters from each other. But in this particular situation, we'll say that the distance between point 1 and point 2 is 6.7 feet. We'll say that it's 6.7 feet. And there you have it. There you have it. So in the next video, we will calculate the midpoint. Where does these 2 points meet up? By using the midpoint, by using the midpoint formula, we will be able to calculate that distance. So I'll see you soon, and thank you for joining me.